Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the fourth lecture of this ongoing course on understanding and reducing greenhouse gas emissions, and we are focusing on scope 1 and 2 emission reduction through building design and construction. In this week, we are looking at calculation of emission reduction through different strategies, and in today's lecture, we are going to look at how can we calculate the emission reduction from by choosing different sources of energy. So far in the past 3 lectures of this week, what we have done is we have looked at how much scope 2 reduction, emission reduction will take place if we have these strategies and we were trying to reduce the energy consumption. So, we used double glazed window instead of single glazed window to reduce the energy consumption and scope 2 emissions thereby. We decided to use the materials, walling materials with lower U value, or fenestration and roof materials with lower U value to get lower heat exchange and hence the energy required to condition the space. That is what we were looking at. Now, this was all reduction, increasing the efficiency and reducing the amount of energy, electricity that will be required, and then carbon emissions. Now, in this particular lecture, today's lecture, what we are seeing is we are trying to produce our own energy on site. So, we are largely looking at the renewable sources of energy. One is the conventional, which is coming from the grid, which is going to give us scope 2 emissions. Now, if we offset that, if I say that I do not purchase electricity from the grid and I am going to generate my energy here, whatever reduced energy is required, how should I make the judgment? What would be my guiding feature? So, before we go to that, and we have already seen the carbon emission factors that are associated with different sources of renewable energy itself, not just renewable, all sources of energy. Now, what we have to know very clearly is that those numbers, the emission factors that we have seen and we will see again, they are the life cycle emission factors that are associated with each unit of electricity produced using this particular source of energy. So, if we say solar cell and it is associated with 41 grams of carbon dioxide emission per kilowatt hour of electricity produced, we are talking about life cycle of the emission. So, it is not just one part or the operational part. It is the entire life cycle that we are looking at. And what does this life cycle include? It includes the mining of raw material, then processing that raw material to get a refined material, then bringing it into a proper form. So, making the wafers and then making cells out of that, and the modules are then ready to be deployed into the PV system. So, this is the system boundary that we are looking at, and this is where we are getting those emissions from. Now, what is missing from this entire thing when we are looking at our project is that we are assuming that this module is available at my site directly, but what are we forgetting is the transportation that is required in between. So, all forms of renewable energy are not going to be feasible or applicable for all sites. Consider having a site in very high mountains where there is hydro which is available. Hydro is also associated with some amount of carbon emissions, which we will see, life cycle carbon emissions, but and it will require construction and fabrication, which is included as part of the life cycle, but not the transportation of the final product. The transportation in between is included, but finally the transportation to the site is excluded. So, what we also have to consider, so what we have already seen is this is the carbon dioxide emission by energy source. So, if we look at say solar, PV solar, approximately 41 grams of carbon dioxide equivalent per kilowatt hour. If we look at wind, which is offshore, we are talking about 12 grams of carbon dioxide, which is very, very low. But is it feasible everywhere? Now, what will change? Scope 2 here is going to change when we are talking about life cycle emissions. Scope 3 partly will be considered. Scope 1 for a lot of cases is not applicable at all. But when we are looking at transporting to the site, we will also be looking at the scope 1 of the emissions that are going to accrue from installation of some of these. So, how much is that going to be? What is more feasible is what we have to keep in mind while selecting. Only these numbers will not work. Let us look at one of the examples. This is not comparing which one to choose, but just giving you an example. For example, if we look at the life cycle carbon dioxide emissions for wind and solar, if we compare between the two, we will see that wind and solar are almost equal, but there is a significant amount of emissions that are resulting when we are decommissioning the project because of the large size, because of the dismantling that will be required. Unlike solar PV, which are smaller modules, easy to shift from a place to the other place. So, decommissioning, so not just commissioning, but decommissioning as part of the life cycle is also important. So, there the wind will have more carbon footprint, a higher carbon footprint. However, overall if we look at the amount of energy produced and the emissions that are going in, we will see that wind will eventually have a lower emission through its life cycle. But as I said again, please remember where is the feasibility, and if we do the scope 1, 2 and 3 calculations diligently, define the system boundary as a large system boundary, we will know clearly which one is going to be having lower carbon footprint, and that is what we should prefer to use. Not encouraging transportation of type of source of energy to far off sites. However, in certain cases, for example, in hills, solar PV is equally unavailable as would be wind, but it is easier to transport and also easier to install and function because there is good sunlight probably that is available. So, that feasibility also will have to be checked when we are talking about the overall feasibility, not even from scope 1, 2 and 3 emission point of view. So, this is what I wanted to discuss from the point of view of selecting the source of energy, source of renewable energy largely. With this, we have completed this entire course on GHG emissions, and the focus has been on building design and construction starting with history. So, thank you very much for joining me in this lecture today. Tomorrow, which will be the last lecture of the course, we will just have an overview of what all we have studied in a week-wise manner. Thank you very much for being here. See you tomorrow. Bye-bye.